Hello students, welcome at Educare. This is Bihani and we are in this chemistry session going to see the importance of valence shell, valence electrons and related to that very important term known as valency. As we know, an atom at its center consists of small positive structure known as nucleus. That was Rutherford's experiment. If you remember, alpha ray scattering experiment given by Rutherford, and detail about its conclusion was atom is mainly divided into two parts. The central part is nucleus and surrounding that all empty space in which there are various shells and subshells. So various cells and subshells, for example, it is the center of the atom is nucleus. This is its first cell, second cell, third cell, fourth cell, so on. So shell number 1, 2, 3, 4, so on. They have such letter symbol also K, L, M, N respectively. Remember, these cells are further divided into the subcells or that correspond that called as orbitals. There are four main orbitals: S, P, D and F. S orbital spherical with capacity 2 electron. P orbital dumbbell shape. Its three subtypes Px, Py and Pz. Total capacity of P orbital is 6. D orbital has 5 types and its total capacity 10 electrons, while F orbital has total capacity of 14 electrons and there are its 7 subtypes. Now, it is necessary to know the meaning of valence shell. The term valence that deals with outermost. Valence shell, that means it is outermost shell. Means if you take example of some element which has suppose 5 shells, then its valence shell will be the 5th shell. That is the outermost shell. It is called as valence shell, and valence electrons are those electrons they are present in the outermost shell. If you take some example, suppose it is of chlorine whose atomic number is 17. Its electronic configuration is shell wise like this 287. Then these are the electrons in outermost shell. They are called valence electrons, and these valence electrons are very important. It is very important their role. Only these electrons, that is outermost shell electrons known as valence electrons, they have the capacity to enter in chemical reaction and in the process of chemical bond formation. So these inner electrons from chlorine, for example this 2 and 8, they will never enter in bond formation. They will not take part in chemical reaction, and only these valence electrons, they have such ability to enter in chemical reaction or to form a chemical bond that may be covalent or ionic bond. Then the valency of element is decided on the basis of number of electrons present in the outermost shell, means on valence electrons. Like we have seen, just chlorine has outermost 7 electron, sodium has such configuration 281 and it has only 1 valence electron. Now this valence electron means their number decide the valency of that element. So valency, as we know, the combining capacity is how many electrons donated or accepted or shared for the formation of chemical bond. That number is valency. And as you see here, chlorine has 7 outermost electrons, those valence electron. It is just 1 electron short to complete the octet, while sodium has 1 electron in outermost shell. Therefore both sodium and chlorine, they have valency 1. We take different example of oxygen whose atomic number 8, whose electronic configuration something like this 2 6. It has 2 electrons short to complete the octet, while carbon has atomic number 6. It has configuration such 2 4, and this oxygen has valency of 2 while carbon has valency 4, which is decided on the basis of these valence electrons respectively in them 6 and 4. Now It is shell-wise and detailed configuration of some elements that we will deal. We'll take few examples, and that examples we will have in order: carbon, atomic number 6, nitrogen, atomic number 7, oxygen, atomic number 8. Carbon has such electronic configuration shell-wise 2, 4. Nitrogen has such shell-wise electron configuration 2, 5, while oxygen has shell-wise configuration 2, 6. We will take detailed configuration of carbon. It is written as 1s2, 2s2, 2p4, means its first shell s orbital has 2 electron, second shell s orbital 2 electron, while second shell p orbital has 4 electron. This nitrogen configuration shell-wise was 2, 5, and now detailed configuration 1s2, 2s2, 2p3. That means these 2 electrons in the first shell of its s orbital, 2 electrons in the second shell of s orbital, and the last 3 electrons, they are in the second shell its p orbital. Now, very important element, oxygen. Its electronic configuration already 2, 6 shell wise, and detailed configuration something like this: 1s2, 2s2, and 2p4. So these 2 electrons in first shell, and this total 2 plus 4, that is 6 electrons in outermost shell. We can have 2 more examples: sodium and chlorine. Sodium atomic number 11, chlorine atomic number 17. Shell-wise configuration sodium like this, chlorine shell-wise electron configuration like this, 2, 8, 7. And now their detailed configuration for sodium is like this: 1s2, 2s2, 2p6, 3s1, while chlorine has 1s2, 2s2, 2p6, 3s2, 3p5. So that is the brief idea about this valence shell, valency, electronic configuration, detailed electronic configuration. If you have liked this video, then share with your friends, subscribe to our channel to know its detail of all our videos. Okay, thanks.